Hello guys, welcome to our channel. My name is Diogo and this guy here is Mauricio.
Hi guys.
Yes, and we are just learning about machine learning and linear regression. And we decided to share with you our knowledge and teach you what we already know. And basically, we're going to teach you how to understand linear regression and also create very fun linear regression code, and I hope you have fun. And if you have any comments during the video, just let below in the comments that we're going to answer in a future video. So basically, we are using Google Colab as a notebook to write our code. If you guys already programmed, so you are probably very understanding of the
Familiar with
familiar. Yes, thank you, Mauricio. We are not from USA or any English country, so if we spell something wrong, sorry already. So if you're familiar with notebooks of Jupyter, you will love Google Colab. And also we're using Python as our language because it's basically the best language to make any machine learning project. And
exactly.
yes, and okay, this first block is just a couple of imports. You guys don't have to remember that. Just when we need to use any of those imports, we are going to tell you that. So don't worry about this first block. The first thing that we have to know is what's a linear regression problem. First, regression. Regression is a problem that happens when you can see a clear correlance between two variables, between an input and an output. So I have an example here, a couple of examples, and we have this X array and this Y array. And if you plot them using matplotlib library here, you can see that there is a correlation between X axis and Y axis. And this correlation is so clear that we can even make this line here to check the correlation. Here, the correlation is not that obvious, but obviously you can try to see, and you're going to see that there is a line, kind of linear correlation. And a regression problem is a problem where you can see this correlation between input and output. And a linear regression is when this correlation is aligned, just how we are seeing here. So, 1 second. Yes, we have those examples here, and we are using matplotlib library. Here's the import from it, and we are going to use this library a lot in the video because we are going to plot a lot of things so that you can see visually the things that we are doing. So we're going to work basically with this data set in the beginning, a made up data set of X and Y. And in the end of the video, we're going to show you how to do with a real data set. So it's going to be fun. And those data sets are basically real world situations. For example, here we made a correlation between years working in a company and the number of times that your wage or salary is going to be increased. If you were working 2 years, your wage are going to be increased 3 times, and 3 years working 4 times increased. And this creates this graph with a linear correlation. And if you know that's a line, let me just annotate again. If you know that's a line, you know that a line has this formula, this pattern. You have in school, normally we learn something like
f of x.
Yes, yes. Oh wait, sorry.
Because y is the f of x.
Yes, where's the reason? Bye bye. Okay, F. Oh, I am so bad at writing.
Click here.
Okay.
Yeah,
this
yeah.
one. Okay. Okay.
F of x
better. Is equals to a plus b x.
Exactly.
Yes, normally is this what we learn at school, but
one
yes,
variable.
one variable, and here is also a line. This one,
theta 0 plus multiplied by x0.
Yes, and theta 1 multiplied by x1. In this case here, this x0 is a dummy input that is always 1, so that we can see this correlation not really important. This one is the one that we are looking for. We are trying to find this data so that we can find the line that best fits in this data set here.
In school, there is a name for them. Is the x-intercept?
X-intercept and the slope.
And the slope.
Yes,
Exactly.
yes. So, second, a linear function always follows this pattern. Y equals to theta 0 x0 plus theta 1 x1 plus, and if you have a lot of inputs, you have a lot of x's and thetas, and you want to find all those thetas because you have already the x's here in the first column, and you have already the y's here in the second column. So you want to find the theta that best fits in this data set.
And you make this same function for all your rows, right? Because each of them are a pair.
Yes, we call a pair of training example. So this the first line work 2 years of work and 3 years of salary, or 2 times salary increase. This is a training example. Actually, training set is the complete
set. Okay.
Yeah, the complete set. So here is a bit wrong. Okay, guys, don't worry. We're going to change that in the next video probably, because these videos are going to be in parts. This is part 1. That's just the intuition and this introductory part. You guys have to understand what's a linear regression and what's a line formula in order to understand the code. Okay, and this is the line formula, and we have here m different training examples. In this case, 1 2 3 4 5 6 7 8 9 10 11 training examples we have here, and the x's are the inputs that we have, and the y is the output, also called tagged values, and the hx is the prediction that we're going to try to make using those training examples 2 3 3 4 and etc. And in the next video we're going to understand what's a cost function. That's also a very important thing to understand in doing linear regression problems. This is all for this video, because this is already a lot of information for you. What's a linear function? What is a linear regression problem? And we see you guys in the next video. If you have any comments, so let below in the comment section. And that's it for today, for this video.